Good evening, everyone, or good afternoon, or good morning, depending on what part of the world you're joining us from. My name is Sam Nasser, and this is the Cleveland C# VB.NET user group. A little bit about the group. We meet once a month. Meetings are free of charge and open to the public, and we cover any and all topics related to .NET. You can find meeting information posted on meetup.com at the link listed at the bottom of the slide. As always, we'd like to give a big thank you to our sponsors, PostSharp and DevExpress, for sponsoring the raffle prizes after the meeting, which will be raffled off using the evaluation forms. We'd like to thank the .NET Foundation for sponsoring the web hosting on Meetup. And last but not least, NIS Technologies for sponsoring the virtual meeting space. We have a special offer from Manning.com. You have an exclusive discount of 35% on a selection of books. And you can find that available at the link listed on the slide, and that will also be shared with you in the chat window. Some general information. Please keep in mind participation is highly encouraged, and the only stupid question is the one not being asked. We cater to a variety of different expertise levels, whether it's students, hobbyists, or professionals, so everyone is welcome to jump in with any questions at any point in time. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And keep it casual but organized. So don't necessarily wait for the moment where the speaker is asking for questions, but feel free to jump in at any point in time. If you have any additional answers or comments or experiences you want to share that go along with the topic, feel free to jump in. But also we want to give enough time for our speaker to go through the slides and the demos. Lastly, as you may have heard, the presentation will be recorded and posted on YouTube, and the link will also be available in chat. Strongly urge you to subscribe to the channel. This way you get notifications when new videos are uploaded. And so with that, we're about to start our feature presentation. And for tonight, it's going to be practical logging and monitoring with .NET Core, and that will be presented by Mitchel Sellers. Mitchel comes to us from Iowa. He's a 12-time Microsoft MVP, ASPInsider, and a DNN MVP, or .NET Nuke. He's also certified in a few certifications from Microsoft, and he is the CEO of IowaComputerGurus. In addition, he has spoken at over 400 sessions at various user groups and conferences globally, and he's the author of multiple books, and he's a regular blogger. In addition, as if that's not enough, he's also actively involved with the open source community, and you can learn more about Mitchel at mitchelsellers.com. And so with that, I will turn it over to Mitchel.
Alrighty, well, thank you, everyone. Appreciate you attending tonight, and thank you for the great introduction. My contact information is here as well. I'll put this back up towards the end of things tonight as well, just in case. Really, I had to stress the importance of questions. If you have questions along the way, feel free to put them in the comments or come off of mute. The presentation I have prepared for you tonight is much based on real experiences and understanding, so sometimes those questions become really additive for anybody in attendance as well. So, and don't hesitate if you don't want to ask today, or if you have something very specific to your organization, your implementation, please do reach out at any point in time. The slides from today, as well as the source code demo that I'll be using to show a few things this evening, are on GitHub, and you can find them on under my public repositories from my GitHub profile. So appreciate everybody's attendance. What we want to talk about today, and what we picked about, why I picked logging as one of the things that I talk about fairly frequently, is looking at what we can do or not do with logging, and why we might want to be looking at logging when maybe we haven't been in the past. We also want to take a look at escalation protocols, and how do we actually escalate log entries and make it so that our logs are actionable, and those actionable things are something that we really have to make sure that our organizations are prepared and ready and able to work with. We can talk a little bit about the sensitivity of those escalation protocols, and I break these out into separate pieces because it's one thing to escalate, it's another thing to escalate things well. And it's really important for us to kind of dig into that. And then we're going to dig into logging in .NET Core and looking at code samples. I have created a few scenarios. The scenarios are really designed to be able to showcase some of the powers of the .NET Core logging ability and making sure that you're able to understand, what's possible, what's not necessarily possible. So why do we start with this? Why do we want to talk about it? And one of the things I always talk with developers about is, well, what logging do you do? What do you have in your application? And so many developers just totally forget about it. They don't understand. They don't think about, oh gosh, do we save IIS logs? Do we save web request logs? Do we have application level logging? Yet, with it being so commonly forgotten, it also has two ties to the OWASP top 10 security vulnerabilities. So one of the vulnerabilities is broken access control, and that has direct references to the utilization and importance of login systems. Looking at logging from a systematic or a control perspective, we're talking about things like, are we logging malicious attempts? Are we logging things such as somebody repeatedly hitting your login page? Are we logging failed access attempts, lockout attempts? And then do we do something with it? And then the last piece that's on the OWASP list is simply insufficient logging and monitoring. And this is the one that typically really throws people for a loop when it comes to planning and application development is, well, what do we mean? Well, when they're talking about insufficient logging or insufficient monitoring, they're typically talking about one of two things. You didn't log something that you were supposed to, or you didn't retain the log that you were supposed to, or you're not looking at your logs. And although they're two completely separate things, we do really talk about them together. And so the things that we're looking at here are going to vary depending on the individual application. But we want to be able to walk through our paths and our application to make sure that we understand what's going on. And I'll talk a little bit more about the types of logging and how some of those will be structured a little bit later. Now, we also talk about logging because there isn't just one way to get it done. And one of the things that I think is most telling, especially in the .NET Core landscape, is that Microsoft's out-of-the-box implementation leaves many questions. So every project that you create by doing File, New Project in Visual Studio, and you choose a .NET Core variety, in the app settings JSON file, you have a login configuration. Most developers don't know what that login configuration does, where it goes, what you could do with it, etc. And rather than digging in and really understanding it, a lot of times it just gets put back to, oh, we'll look at that later, we'll look at that later. So we're trying to be practical with what we're talking about and taking that thing that came as an out-of-the-box solution for Microsoft that maybe did a little bit and turn it into something that actually meets business needs, make sure that you aren't vulnerable to some of the most common security vulnerabilities, and then educating on other options and things that we can do to make our lives a little bit better. In the virtual world, it's a little bit harder to do this, but I want you to be thinking throughout everything that we talk about tonight, do you actively include logging code in your applications today? It's important to understand what you might be working with on your side and understanding if you have something and you're not maintaining it, you may need to double back. But if you're not, should you? I then want you to think about, do you have a documented process to escalate logging events? And this is a really interesting one depending on the industries that you're in, depending on the verticals that you're in. But do you do something with those logs? If you get errors, do you actually have somebody that knows about them? Do you review them? And then regardless of escalation, do you look at your logs? And what I mean here is not just, oh gosh, an error happened. I'm talking about, what data are we logging? How much log data is an average day? I'm talking about truly looking at a regular analysis of the information that you're logging from your application. Because not only is it important enough to have escalation processes in place, it's also important for you to be able to quantify and understand what is normal. because what's normal in your application may not be normal in others. I really liken a Azure specific scenario that's came up with a few of our clients, in that a really chatty application, if you turn on database auditing and some of the tools in Azure, your spend becomes incredibly high because the database is way too chatty. A system that has 200 database calls per web request results in a lot of log data. So by looking at those logs, we will be able to understand, holy cow, we've got all of this activity going on and we have all of this log ingestion. Is this right? Because what you'll do is you'll spot things that maybe weren't configured correctly. They're maybe configured close, but they maybe didn't get you everything that you needed throughout time. So always be thinking about this, not only today, but think about this as you go back to work tomorrow or next week or next month. What are you doing with those logs, and are you doing the right things with them? So now, when we talk about logging, it's important to think about what our uses of logging are. And I'd like to break things out into typically 3 overall buckets of use types. Diagnostic information is typically the most common thing that individuals think of. And this is your standard debug style messaging for trying to figure out what's going on with your application. Now, I say debug here, it may not necessarily be debug, but these are the kinds of things. I started this method, I ended this method, I entered this process, I exited this process, right? It's stuff that allows you to truly diagnose what the application is doing. Oh, did this execute? Did that execute? Why did that execute? Oftentimes we think about this in lower level environments. So we think about these kinds of things being, oh, this is what's turned on in dev. Oh, this is what we use when QA is trying to figure out what's going on. That may not be the case in the end result, but the idea here is you have that basic information. It's developer focused. This is the stuff that almost everybody thinks about. The next step, though, is audit style information. So these are things that you might write in your application that are designed to track or document a user's progression or the user's actions within your application. Think about this as a way to document critical path or sensitive data access. For example, user 15 accessed the administration screen. User 27 made a credit card purchase with this transaction ID. You want to be thinking about anything like that where you may be able to do some sort of audit information, so that if you came by in the future and needed to look at, well, what did this person do while they were in my system? You're going to use that log information to really be able to retrace that individual steps. You're going to use that information to potentially take an action, notify people of a data breach or whatever else you may need to do. If we look at the things that happen automatically out of the .NET world, if you look at ASP.NET Identity, it, for example, logs invalid password attempts to the log stream, because again, that's a serious thing that we're looking for. It doesn't log, from a warning perspective, a successful login, because that's less risky, less chance of that being something that we need to look at. Now, I always encourage people as well. We're talking today about audit information inside of our C# code. Don't forget about the other stuff that might be able to take care of logging. This would include things like IIS logs, SQL Server logs. Anything like that falls into these same buckets, although different implementations. But be sure to be thinking about all of these other areas, other elements, when you're putting together a comprehensive plan for logging within your organizations. The last piece, and one of the ways that you can become the rock star from a developer perspective, is to handle exception reporting, knowing when your application has critical issues. If you get an immediate alert when your application has a critical error and it's something that you haven't seen before, it allows you to have a leg up on your users to be able to go through and document and implement a fix that might impact the users of your application. And the idea behind this is to be able to get in there and start resolving something even before your users come to you with the issue. Because at this point, right, you might be able to find the issue and fix it. Great, you're the rock star. But at minimum, if you knew about the error, you might be able to reach out to the user if you know who it was, or when that user comes into your help desk and says, oh my gosh, I just encountered this error, you'd be like, oh great, yes, we did see something about that, and you might be able to ask them more pointed questions when it's still fresh in their minds what they were doing within your application. Now, obviously, there's other things that you can do, but at the highest level, this is that fundamental, what do we use logging for? Now, as we take this one step forward, we have to take a look at the sensitivity and security of the information that we're working with, because we're just talking about logging and potentially showcasing, oh, this user failed to log in, or this user got locked out, or this person accessed this functionality. So looking at the security of our logs becomes really important. When we talk about the security of the logging, we're talking about typically 3 or 4 things, right? The physical security of our logs, the retention policy of the logs, as well as the included information. Now, I would love to sit here and tell you, I can give you absolute answers on how to deal with all of these things. The problem is it's often a very fine line. Individual organizations may be subject to different regulations. For example, those that work with the European Union are subject to GDPR. GDPR really limits some of the things that you can store on a regular basis. The key here is to understand what you're doing, what your application is doing, and where you want to go. Now, I'm going to drive into this just a little bit more because it's something that people don't often think about. Physical security is the one that trips people up most commonly. Some people say, well, okay, we're talking about people getting access to the physical data center. Well, that is definitely something that we want to worry about. We want to worry about developers grabbing a copy of the production logs, right, and running off with it. But the one thing we've seen more commonly recently is developers that just write their logs to a logs directory with a commonly guessable name, and it is a text file. Well, guess what? We don't want random website users to be able to get to our logs either. So don't just think about that security from a, oh gosh, they can't get to the server. Be thinking about where they're stored, how they're accessed, and how somebody that has malicious intent might be able to gain access to them as well. Retention becomes your other piece. Retention of logs, especially for high activity sites, it's not free, it's not easy. So balancing how long you want to go. A good example that I give for folks is when you look at e-commerce transactions. An e-commerce transaction, the current rules state for the most part, right, that you can dispute your credit card charge for up to 60 days. Now there's exemptions to that, there's other things that can come into play, but it kind of sets at least a minimum for me, right? If I'm running an e-commerce platform and somebody can dispute the transaction for 60 days from date of purchase, well, by golly, I know how long I'm keeping my data for, right? At least 60 days. So be looking at your application and look at the potential balances of security from a regulation perspective to security of how your application works, and try to answer and create a plan to deal with your login concerns all within that the collective confines of those different rules. Everyone's going to be different. Some applications, there just isn't enough critical stuff to even worry about a lot of this. So just be thinking about what you're doing and what you might be able to do. Now, when we start to go into then some of the aspects of reacting to our log message, we start to ask questions about escalation. So we get these error messages, we get these warning messages. Now we need to find a way to tell somebody about it. And this is where putting the login information in the best location becomes the most critical thing that you can do. Any extremes in this configuration, whether it be the amount of log data just being visible or notifications included with those log messages, can substantially reduce the effectiveness of your overall login system. A great example is something that happened to a client of mine a couple of years ago. They implemented a login system that treated every 404 as a critical error because the thought was, oh gosh, we might have missed a redirect when the site went live. So every single encountered 404 resulted in an email. As you can imagine, that didn't end well. Filters got created taking anything from the logging system and it put it straight into the trash can. The people building the filters did not care that they could have done a subject line restriction or something else. They were just tired of getting their email boxes filled up with errors. So making sure that you match the information need with the people that are receiving it, and think about things like, will a end user's usage of your application potentially put you at a situation where you're at risk of being overwhelmed by a third party, right? Do you need to perform deduplication or anything like that is something that you want to think about. Now, where people often get tripped up is what options are available to us. When we look at our default options, when you look at the configuration from File New Project within Visual Studio, we have the ability to take these log entries and write them to the console. We have the ability to write them to application insights. We have the ability to write them to the debug window, as well as event source. Now, event source, for those of you that aren't familiar, that's essentially the Windows event log type login. Now, this makes accomplishing this task, right, of notifying others a little bit harder. So we have to expand ourselves out and look at third-party solutions. There's third-party solutions out there that allow you to go to file, a rolling file scenario. So in other words, a file per day, a file per hour, a file per month, directly to email, Azure storage, Azure table storage, SEQ, which I'll talk about in a little bit here as well. So it's something that can be done. And then we have to simply take a look at, what do we do to create an escalation protocol that works and meets all of these other criteria? And what we've found is that most commonly, you're going to have multiple escalation protocols and multiple storage locations, depending on the severity and nature of the messages that you're responding to. So what I'm talking about here is a way to be able to manage your application's logs, but also manage the expectations of the development team. And what we've found so far is that the most common way to do this is to have a dual configuration of log entries, and we split them based on their severity. Errors. So these are those exceptions. You shouldn't be logging an error for things that aren't actually errors. And in this case, we want to take those and log them locally to the file system, because that's where our final aggregate complete log information is included. We also want to send those to an outside service. And what I say here is, for an outside service, is I want to get them away from the server. I want to collect the data from our application. I want to escalate the fact that it is an error, but I don't want to take processing overhead or other impacts to my production environment. I want it to be logged and then shoot it off and let something else handle it. And the idea behind this is to limit the impact when you have a critical error, or when you have repeated critical errors, that you don't overwhelm your server. So in the example of the configuration that I mentioned earlier, where every 404 sent an email, you can imagine what happened. Not only did it overwhelm the end users, it actually overwhelmed server resources in some ways, because every single 404 was sitting out there and sending an SMTP message and waiting for the response from the server to acknowledge that it was received. So we're doing things there that we didn't necessarily need to do. Any ability of like deduplicating or otherwise, right, was on the application code's responsibility. Now, going to that next step, We also want to take care of anything else that we want to look at, but this is information that we maybe just want to log locally to the file system, and we look at it when we need to. We want to keep 30 days, right? In a perfect world, obviously we would still use an external service rather than the local file system or something like that. But I wanted to make sure that we talked about a scenario, right, that has limited requirements for you to do something special, custom, or third party that has a cost within your application. And to make things even better, it would be amazing if these thresholds or adjustments to the logging levels could be done by an outside source. So one of the examples, one of the tools I'll show you in just a couple of minutes has an ability to actually dynamically change from logging errors only to logging warnings to logging informational, even all the way down to debug potentially in real time in production without triggering your application to restart, all using the out-of-the-box native.NET core logging systems. So it's a matter of finding a way to get quick access to these detailed log messages. So if they're logged locally to your file system and you can get there, great, awesome. If you're in a corporate environment that has really strong IT policies where the development teams do not have access to the file system, which is a good practice, you may need to look at different systems to be able to meet those same escalation pattern processes. So with all of this being said, what kinds of things are we looking at with logging in .NET Core, and why does this all tie together into a overall problem? Well, logging in .NET, whether it's .NET 6, .NET 7, .NET 5, the out-of-the-box solution is turned on. It logs things to the console or debug, but it has limited targets. So most people ignore it. But what's important to understand is that it's a single source logging stream, meaning everything that gets logged is there. So if ASP.NET writes a log message, you can get access to it. If Entity Framework writes a log message, you can get access to it. And it can be filtered out by type and category. And Microsoft does some initial filtering, which is why people often overlook some of the information that might exist in that log stream. And this is where it becomes really important for you as developers to understand that by getting access to this information, by storing this information, you're going to be able to find things that you might not necessarily see otherwise. A great example for those of you that are using Entity Framework, if you create a decimal column type and you're using Entity Framework migrations, and you do not specify a precision and scale for that decimal, and you don't have any global setups to be able to define that, you are going to be able to build your project just fine. You're going to be able to create migrations just fine. You're going to be able to apply migrations. Your application is going to run absolutely fine. No build warnings, no build errors. Everything's going to work. However, every single time your application starts, every single decimal column in your model that is missing a precision and scale definition will write a warning to the log stream that says this field is not configured for optimal precision and scale or something like that. And so by not looking at that logging stream, you might actually be missing things where you could optimize your code or improve your code overall, which just gives even more credence to the need to try to take something and run with it. So now, how do we bridge this gap? Well, there's many different ways to bridge the gap. Where I'm going to go today and show you is leveraging an open source project called Serilog to take and allow this detailed configuration to grab this log stream and be able to do something with these items. In addition to this, the open source product, the creator of that, Nicholas, gosh, I can't think of the pronunciation of his last name, but the creator of Serilog has a commercial company called DataLust, which has a product called SEQ, which does the log reporting, analytics, search engine kind of features for you as well. So I'll talk about how you could utilize Serilog to push all the way out to SEQ, which is that product. But there are other pathways. So some people that have been around in the .NET space for a long time, right? You're using Log4net back in the day. If that's what you like, if that's what you love, you can keep doing that. You have access to the same things. How exactly you configure Log4net is going to be a little bit different than some of the specific stuff that I'm going to talk about with Serilog tonight. But at the end of the day, there are other ways to do this. I'm simply showing you one of the pathways with some of the best overall support from a license model perspective, cost perspective, etc. Some other things that you might get that you haven't thought about with this combined log stream is bottleneck or optimization things that might be missed. So ASP.NET Entity Framework logs out things such as this is how long this query ran, or you can update it to show you what exact SQL query was executed. What was the amount of time for each of these? You can do a full breadcrumb of traffic patterns. One of the most common things is you build a custom route and you think you knew exactly how it was supposed to work, but it oddly matched to a different controller. If you tell Microsoft to report more information, you'll actually be able to get, oh, this is how it started, this is why it matched this, and figure out why things didn't necessarily work the way that you wanted them to. So a quick look just into, what some of the more structured, things look like. This is an example of a email alert from a structured message. You'll see it's just a combination of overall message information. So for example, this post responded with a 500 error in 17 milliseconds. And then here's a bunch of detail. You can also see here, we're looking at a number of log entries here. So, oh gosh, this person tried to access a disabled account. This username was invalid. This connection had an unexpected error. This kind of thing. This is the SEQ product. But again, just kind of gives you an idea of like, oh gosh, I get a good glance right here. This is a 30-minute window, and we can see that we had a fair number of issues. The idea behind this is, again, I want to be able to get a quick glance. Do I have a problem? Is there something going wrong? You can click in and get even more detail. For example, here, this is just clicking on one of those entries. And you can even see like, oh, this was the request path. This is the context of where things happened. This is the error, etc. Driving in even more, we can enhance this log information with other things. So for example, we are pushing in this user ID field. This allows us to be able to then associate what user actually encountered the problem, and maybe we can reach out and help them. Maybe we can go reach out to the database and try to do something with it. Now, the last thing that I like to do before we get into the code examples is to talk just a little bit about how we write our log messages. So string interpolation was added a long time ago in the C# world. And I see developers all of the time wanting to write log messages using a interpolated string. So in other words, using the $, right, before their double quote. And we don't want to do that with our log messages. So the way that you write a log message, this is where you use any of the .NET Core iLogger implementations, and you do things like log information or log error, log warning. What you're doing is you're sending in a message template, and then after that, it's an array of parameters for the things that you provided in that template. So in this case, what we're trying to do is we're trying to log out a informational message. The template is user information, and then, oh, drop the user, and then I'm just saying here it's the request object. This is purposely a little bit different just to show you what an error looks like. If I do this, you'll see something that looks like this. What this ends up doing is calls toString on anything that is over here. So this is a message template that says, oh, user information and a variable, if you will, user, and then this is the value that gets dropped in there. The reason why this becomes so important is when we start using structured data tools to analyze our logs, they aggregate and can group our error messages for us to see frequency of error, to be able to chart variability of an error by the template. So in other words, this means that every single time this happens, regardless of what request object or what's going on, I'm going to be able to get all of those like error messages. The second that you turn that message into a unique string for every single error and you don't have that token information in there, the structured data tools are no longer able to go in and aggregate for you. They're no longer able to go find what other errors may have happened unless it's for the exact same person or for the exact same value. Now, there is an ability that's really cool with this process to tell .NET, rather than output into my structured login a call to toString, which you can see here is what was done before. You can utilize an @ moniker inside of these tokens, and it is going to attempt to a JSON dump of that entire object. Now, where this gets tricky is it's going to do a JSON dump of the entire object. That's a good thing and a bad thing. As we were talking about earlier, the sensitivity and security of the information that we're logging can become very, very critical. So as you see here, this is just a snippet, but this log entry literally dumps every single variable, every single property, nested, deep, etc., which may very well have sensitive information in. So use this wisely. I recommend that if you're not doing things like using a static code analysis tool, at minimum be looking for these kinds of things in your code developer reviews. A lot of the tools that are out there that do static source code analysis, such as like SonarQube, etc., actually catch these kinds of things and bring them to the surface as warnings. So it's a very common thing that may happen. But as you can see, right, you could have a real problem here if you dumped the wrong particular object. Not only that, from a sensitivity perspective, you can also have problems from a pure data size. If you do that with the request object, it's just a little bit under 5 megabytes per web request to do a full dump of the request object. So not something that you want to be doing in your login systems in production. So what I want to do is get a couple links here, and again, I'll put these back up in a little bit, but I've got a source code demo that kind of shows you how to take, it takes a regular ASP.NET project and implements login to solve a couple of things, demonstrates how you can play with turning the levels up and down to be able to see entity framework information, and then it has an implementation with Serialog. So I will get things ready to switch over to that source code example here in just a second. Anybody wants to copy out links, and again, I'll make sure to make this available. While I do that, are there any questions? I haven't seen anything in chat yet, but can I give everybody a couple minutes here to ask any questions before I dive into the code specific bits? All right, so again, as I mentioned, what I wanted to try to do here is to show you where do things go from a regular ASP.NET web application into something that accomplishes some of these logging goals. What does that look like for you? And so what I did with this project is I set it up the way that we set up all of our projects. The goals that we had with this are very similar to what I was talking about earlier. We want to make sure that whatever level of detail we want to log gets logged to either the local console or file system. we want to then make sure that we have an escalation criteria where we could do things more granular. In addition to this, one of the things that we know that happens a lot for developers is you do something that causes a failure in your startup code. And those are some of the most complicated things to diagnose, because when the application fails to start, you don't get a lot of detail. So we wanted to make sure that we wired up everything with our login configuration so that we had login available to us prior to calling the startup code. And the goal with that was, let's just say I registered something for dependency injection and I didn't have the implementation in there and it wasn't able to properly work. Or I missed registering something for dependency injection and it wasn't able to work. By getting our application adjusted so that we can use logging at the startup process, we're able to get access to that information. So to accomplish this, we only had to make a couple of small changes to the project. If we look at the project file itself, we notice that we have a couple of package references that were added. Now, I added things very, very explicitly here. These last two are not actually needed, but I did this to be able to demonstrate and talk through everything that we need to do to be able to accomplish this in our projects. So we first of all add serilog.ASP.NET Core. This is the package that allows us to utilize Serilog, and it has some of the helpers to be able to tie into ASP.NET Core and do all of the things that we need to do. The next one here is Serilog Enrichers.Correlation ID. An enricher in Serilog speak is anything that enriches log information with something else. And what this does is it adds a correlation ID. And the idea behind this is a correlation ID is a unique identifier that is assigned to each web request. And what this does is it adds that payload to every single log message of that web request. So you would be able to go and look at your logs and look at a particular correlation ID and look at every single log entry for just that single web request by utilizing that correlation ID. So it's a really helpful thing. I think it makes diagnostics so much easier as a developer. So something that we always include in our projects. And then the third one here is Serilog.settings.configuration. So this is what allows Serilog to read its configuration settings from a configuration file, okay? The bottom two, again, I mentioned those aren't necessary because they're default ones that are included, but I wanted to be able to talk through the concept of a sink. In Serilog's nomenclature, a sink is nothing more than a destination for your log entries. So in this case, I explicitly added the console sync and the file sync to our project. Now, if I do just this and nothing else, nothing is going to change in my application, okay? This is just simply to bring those package references in. We have to wire up and set Serilog as our log source, which we will do with 2 additional steps. Our app settings JSON file is something that I've expanded to provide the information that Serilog needs. If we look at what a default configuration file looks like, you'll see here, logging, log level, okay, default is debug, system is information, Microsoft is information. Okay, now let's go look at what we're doing now. We don't have a logging section. We have a Serilog section, which because we're using Serilog's configuration, it's very important. It's got to be named Serilog. And then in here we say, hey, we're using the console sync and the file sync. We are enriching with log context, with machine name, with thread ID, and with correlation ID. So in other words, we're adding these things. I want to write our log entries to 2 locations. I want to write them to the console, and I want them to write to a file. But oh yes, in addition, for file, the path is this. I want to restrict it to information, and then I want it to look like this from a individual line perspective, okay? The idea behind this is that's where I do all of my configuration. Now, if you notice, I skipped over the minimum level because there's a little bit more to this minimum level concept. So in this case, we have a minimum level and a default of debug. This should make sense, right? We're saying that I actually want to listen to debug, information, warning, and error messages. And then we have overrides. These overrides are where we say, hey, I want different bits of information. So I could do something like this, for example. Regular Microsoft stuff, I only want warnings. System stuff, I want informational. Microsoft Entity Framework Core Database Command, I want informational. This specifically is the entry that allows Entity Framework to log out all of your database commands. So you're utilizing those namespaces to control what does or does not make it into your final logs. And then you can see down here, we override this to information. The reason why this is important to understand, though, is that whatever is set here as your default, that is the bare minimum. You cannot go lower than your default. So if I set my default to be warning, there is no way for me to override here or here to get access to anything informational, debug, or otherwise. So if you need to, by default, go with a lower level severity from a default, and then restrict things more specifically either with your write destinations or by specific object types or otherwise. So then how do we wire this all up? Well, the process to wire things up is fairly simple, and it requires you to just make a couple of changes to your program CS. Now, obviously, if you're using the newer style syntax with the class size, you can do it with those as well. It's just a little bit more complicated. But basically, we create our own iConfiguration using a configuration builder to bring in whatever information we need. So in my case, I'm bringing in my app settings JSON file. It's not optional. It does reload on change. I bring in any environment variables because maybe I want to override something, and then I build it. This configuration instance is only utilized to do the initial setup of the logging system. And that's what's done right here. So we simply set Serilogs global logger, which hooks into everything else, and say that logger configuration, read from configuration, and then we pass it our configuration instance, and then we create the logger. So the very, very first thing that we do is we try to get logging working. Now, if this file doesn't exist, your application is not going to start. Other than that, right, you're going to be able to get your application started. We then, inside of a try-catch, work to build and run our web application. So in this case, I have an informational log message that says, hey, starting our web host. We start our builder, we run it. If an unhandled exception happens and the host terminates, we log that as a fatal error. And finally, at the very end, we close and flush our log stream. And the idea here is if it fails to start, we get an unhandled, a truly globally unhandled exception. We can catch it, log it, gracefully save those log entries to the file system, and then exit our application. The last piece then of configuration is when we build our host builder, before we say that we want to utilize our startup class, we ensure that Serilog has all of its ASP.NET knowledge registered so that when the application starts, it's able to report on anything successful or unsuccessful with regards to ASP.NET configuration or otherwise. So this allows us to get a nice log entry that shows things such as starting the web host, We then see things like, oh, user profile is available, and here's where the data protection keys are stored. For those of us that have had some fun with data protection keys, it's a great way to look at where those might be. We can see that it was unable to, bind because I had maybe another application running. And then we can see here, we start to see Microsoft information. Oh, this request is starting. Identity application was not authenticated. Okay, now we're executing this endpoint. We matched this route. We did all of this kind of stuff. And then this very last entry here is one that Serilog adds for us, which is an aggregate of all of these other Microsoft messages and simply says, hey, a get happened for this URL. It responded with 200 in this much time. So how we get some of the more granular configuration is we can tweak things inside of our startup code. Everything up here in configure services is exactly the same as what you normally have. But down here in the configure method, we have a couple of extra things that we do. So we can simply say, hey, we want to use Serilog's request login. That adds some default, individual single line methods. So method, path, and timing. And then we go one step further and say, hey, you know what? I also want to enrich our login context by adding the request user by setting the user's name. And this will be in anywhere in our application that we have a log message. And the idea here is you can inject whatever you want. This is something that would be done globally for every single request. It's important to watch what you put in here. But one of the best examples of purposes for this is dropping a user ID out here. Some folks like to drop server name out in this scenario as well, so that you could do something like that, or load balancer name, or something that can't be obtained through other mechanisms. Now, everywhere else in our application, we use logging just like the way that Microsoft Documents using it. We can use dependency injection to inject an iLogger of T. So in this case, right, iLogger home controller. And then anywhere that we want to do a log entry, we can literally do logger, log warning, log information, etc. Everything from here is normal. The initial setup, the Serilog configuration, it's set it and forget it, and now you'll get those messages. So as you can see here, when we go, I have an index page, I have a trigger warning page, which simply logs a warning message. I have a complex one that calls, does those two different examples that we were looking at. And then we've got two pages that just have some information as well as an overall error. I will run the application and just kind of click through a couple of these for you, just so you can see some of the log messages. Bear with me 1 second here. There we go. So we'll trigger the warning, we'll trigger the complex login. I'll look at this, and then I'll do one attempted entity framework query. There we go. All right, so I did a couple of things just to give you a little bit of, hopefully get us a little bit of a more detailed log. So you'll see here, okay, we started the log, or started the web host. We had a get that responded with this, null visited privacy page at with this timestamp. So if we look here, when I viewed the privacy page, we have some other, or this was my note here of a warning, username, which was null, visited privacy page at this particular timestamp. We go and look a little bit further, we can see that there were gets for other pages. And then now we can see those two examples. And this is where it's really kind of, even for an unauthenticated user, look at how much information with the claims and other information was actually output. And then you can see a little bit further on, I tried to log in. And you can see here, oh, we executed a database command. It took 60 milliseconds. It had a parameter of normalized username, which was a string of 250 up to 256 characters with a 30-second command timeout. And then here's the query that we ran. Select top one with these fields from ASP.NET users where normalized username equals this. So this gives me some really good insight on what's going on within our application. Now, if you really wanted to dial this up and see that example, right, I can change Microsoft to debug. Actually, I'll do Microsoft just information. We'll do debug in both places, just to give you an idea of the extreme amount of information that you can get at your fingertips. So just application startup alone, let me see if I can access the log file. Yeah, I can't quite access it yet. So let me do this. I'm going to just do 2 page views, go out of here and come back in. So now we can see that we have a lot more information for just 2 basic web requests. So we see here we have our starting web host, user profile, and then now we can see again that diagnostic of what Microsoft is doing for each of our individual page views. And this is where it can become, again, very beneficial from a debugging perspective. This request started. We are executing this endpoint because we matched this route. Then we go and are executing this action. It returned this type of result, and there's how quick it was. Now we're starting to do our view and do our other diagnostics. So if you've got a page that's failing, a page that's slow, by turning on this deeper level of diagnostics, it's really kind of interesting to be able to look at, oh, it took me not even a millisecond for my controller to execute, but it took 290 milliseconds for my view result to be created, which then means my overall time was 354. So like you can start to piece together what is slow, what is fast, etc. And that can also help you get your diagnostic information. So by just doing this with a little bit of configuration, we now have actionable, workable log information, and we're able to, figure out what's going on with our applications and stop the random errors from happening without necessarily being locked in. So with that, I'll open up for any questions that folks may have. I hope things were beneficial. Hope you learned something from this tonight. Give it just a second here, then otherwise, Sam, we can turn it back over to you.
So Mitchell, thanks for a great presentation. Before everyone starts leaving, just have a couple wrap-up announcements that I'd like to go through. All right, so thanks again to Mitchell for a great presentation, very insightful, and we appreciate you taking the time to present. So as far as the presentation, it will be recorded and will be edited in the next couple of days and will be uploaded to YouTube. The link has been posted in chat. I strongly urge you to subscribe to the channel. This way you get upload notifications. And then tech events will be posted on my blog, samnasser.blogspot.com, and we'll go through those in just a little bit. And then lastly, please fill out the eval forms. That link is also posted in chat. This way we can provide Mitchell some valuable feedback. Once again, for those that joined us after the start of the meeting, we get a 35% off from Manning.com on a specific selection of books, and the link is also available in chat. And the discount code for that is MTPCLEC21. As far as technical events coming up, on August 4th, which is next Thursday, is the Twin Cities.NET user group that meets in Twin Cities, Minnesota. And they're also going to be presenting online. On August 10th is Azure Cleveland, and we're going to be having Joe DeAntoni, I believe is how you pronounce his last name, and he will be talking about Azure Active Directory for data professionals. On August 18th is the Greater Lakes usersgroup.net. They also meet online, and that will be on the third Thursday, which is August 18th. And then on the fourth Thursday, August 25th, will be the August meeting of this group, and we'll be meeting at 6 p.m. Eastern as we always do. And you can find meeting information for all these meetups over on meetup.com with the links posted there, and they will also be posted on my blog. With regards to conferences, Cincy Deliver will be taking place tomorrow in Cincinnati, and that is a combination of both agile and development topics, and tickets are still available for that. On August 8th through the 10th, which is next week, is KCDC, or Kansas City Developers Conference, and the link for that is kcdc.info. And then August 17th through 19th in Louisville, Kentucky is codepalooza.com. And I will be presenting there on August 19th on Azure Machine Learning. So join me and attend the conference. In addition, we always like to discuss job openings. Tech Systems always has job openings available at techsystems.com/itjobs, but always like to ask who's hiring. If you know of anyone who's hiring, or if your current organization's hiring, feel free to jump in verbally or in chat. In addition, if you're looking for work, feel free to make yourself known. And you can always email me afterwards as well if you care for a more private conversation. My contact information, snasser@nistechnologies.com. And you can also find me on Twitter @SamNasser. And the link to my blog is samnasser.blogspot.com, where I will be posting the technical events. And then lastly, I invite you to connect with me on LinkedIn. And so with that, if there are no questions or comments, I would like to give a big thank you again to Mitchell for joining us, and thank you to all for joining us from whichever part of the globe you came in from. And look forward to seeing you next month. Good night, everyone.